Do you remember AI, the American science fiction drama directed by Steven Spielberg? The movie played in late 22nd century and featured the story of David, a childlike android programmed with ability to love. We are not yet in the 22nd century, but it is undeniable that machines are beginning to build human-like capabilities. And frankly speaking, AI has already proven to be better than human in many aspects. AI is a system that is able to exhibit traits of human intelligence like reasoning, learning from experience, or interacting with humans in natural language. This definition feels intuitive, but it is a bit ambiguous, mainly because what we can consider intelligent changes over time. Is it intelligent to calculate the square root of pi in a few milliseconds? Is it intelligent to play chess like Deep Blue did? Or is it intelligent to speak like Siri? The answer to these questions are subjective and are not the same today compared to 20 years ago. To make it slightly more objective, we can distinguish two types of AI: general AI and narrow AI. General AI is typically what you see in movies, a complete system that is indistinguishable from human. It knows or can learn anything humans can learn, has emotions, even has a purpose in life. Narrow AI is less ambitious. It is when a system exhibits human-like intelligent traits on a specific field or task. Today, we don't know how to build general AI, but we became very good at building narrow AI. This is because the individual ingredients of narrow AI, as we described them earlier, were ready. They are sufficient processing power, lots of available data, and last but not the least, the right set of techniques and algorithms. Now, what are those algorithms that allow us to build intelligent machine? First of all, we know it should not be an explicit procedure. For example, one that describes all the criteria to recognize a bird in a picture. Try to write such a list. You will see how difficult it is. So on the contrary, we need to write algorithm capable of looking at thousands of bird pictures and inferring from them some explicit way to recognize a bird. It doesn't need to be explainable as long as it works when tested on a new set of pictures. This is what we call as machine learning. One popular way of writing such machine learning algorithm today was inspired by the way our brain works. It's called as neural networks. To describe it in a very simple way, the algorithm takes the input data, say a picture of a bird, feeds into artificial neuron that works together to recognize. For example, it identifies that the bird in the picture is pigeon. Neural networks are scalable technology. You can combine many layers of neurons in what we call as deep learning algorithm, and that to achieve more complex functions. Some of the examples are like to estimate arrival of millions of Uber rides based on city traffic history, or create application for handwriting recognition, or image compression or stock exchange prediction. No wonder we see most of the big players investing heavily in AI, with Google buying AI startup DeepMind in 2014 for $400 million, Microsoft Venture investing into startups like Algo and Bonsai, and Amazon even building their own Amazon AI entity with Amazon Echo being their first mainstream product. And this is not a game for technology giants only. Global investment in AI went from 0.6 million in 2012 to approximately 5 billion in 2016 and around 12.5 billion in 2017. The growth is expected to continue throughout 2020 when the revenue will be close to 50 billion. More than 60% of executives in a joint MIT and BCG survey believed AI will have a large effect on the business in the next 5 years, with industries like telecommunication and financial services probably leading the way. So, what are the fundamentals of AI? They are computing power, learning algorithm, and training data. Let's look at each one separately. Computing power is becoming more and more a commodity. So unless you are in a very specialized industry, you won't be competing there, and you are likely to use off-the-shelf computing infrastructure, potentially on pay-per-use basis. Algorithm is again a commodity and is a lively field of research. Last but not the least, the training data, which is a competitive advantage for any organization. But the key thing here to understand is that no algorithm can make up for missing or low quality data. Remember this very simple rule about AI: garbage in and garbage out. So ensure you have a quality data for AI applications. Let's look at some of the challenges in AI world. The most sophisticated AI algorithms are black boxes that learn from experiences to make their choices, but no one is able to explicitly identify. Also, the other challenge is which input variable or which past experience lead to which choice. This is a serious ethical and sometimes legal implication we see in AI related application. In 2015, for example, a study has demonstrated that AI algorithm can develop discrimination based on race or gender. So even in short and medium term, AI raises ethical questions that still require policy and regulatory answer. Thank you.